Hello friends, today we will discuss about our new topic refraction. But before I start refraction, we already know about ray. What is ray? So we can say that the path of light or the direction of light propagating is known as ray. Right? We know that light travels in a straight line, right? Okay, then we also know that some surface are which they allow to pass ray, like glass or water surface, right? But some surface of wall, steel, so this surface does not allow to pass a ray of light, right? Okay. Now we already study about reflection. We know that the ray incident on a surface and return back. This process is known as, or this phenomena is known as reflection. We also know about laws of reflection, that incident ray, reflected ray and normal are same in plane or are in same plane, right? Okay. And second is second law of reflection is that the angle of incident and angle of reflection are same. Now today we will discuss about refraction, right? Friends, you already study about this topic in your standard 10. You know the basic of reflection. You know that the direction of propagation of incident ray that enters the other medium changes at the interface of the two media, right? I write that the direction of propagation of an incident ray of light that enters the other medium changes at the interface of the two medium. This phenomena is known as refraction, right? We can say that the direction of propagation of incident ray of light that enters the other medium changes at the interface of the two medium. This phenomena is known as refraction, right? So friends, we all know that speed of light in free space is 3 into 10 raised to 8 meter per second, right? Okay, good. But we know that this ray of light passes through a different medium, right? Okay, when this light or ray of light passes through a different medium, the speed of light changes, and this speed of light change causes the change in direction of a incident ray. I repeat, friends, we all know The speed of light in free space is 3 into 10 raised to 8 meter per second. But this ray of light has to pass through a different mediums. As this ray of light passes through the different medium, the speed of light changes, and this change causes the change in direction of ray, and this is known as refraction. Right? Okay. So see this figure. This is our interface of medium 1 and medium 2. Right? Medium 2. Here friends, this is our normal. Right? So here a ray is incident at this point. Here suppose the interface is PQ. Incident ray AB incident at point B. Right? After the incident, the direction of propagation of incident ray, here it has to pass like this, but the direction is changed. So this incident ray passes like this. So this is our refracted ray. Right? So here we write that here this is incident ray and this is our refracted ray. Here PQ interface of medium 1 and medium 2. AB is incident ray. Here BC, this BC is refracted ray. Here we know that the angle between incident ray and normal to the surface is known as angle of incident. Here we can denote it angle of incident by I. Okay. The angle between refracted ray and normal, here this angle is known as angle of refraction. I repeat, the angle between incident ray and normal to the surface is known as angle of incidence, and the angle between refracted ray and normal is known as angle of refraction. Right? Okay. Okay friends, so from the figure we can write that the surface separating the two medium is PQ. Here incident ray is AB, so incident ray is equals to AB. Here BC is refracted ray is equals to BC. Here angle between incident ray and normal is known as angle of incidence. So angle ABD, angle of incidence. Here angle between refracted ray and normal is known as angle of refraction. So here angle EBC is known as angle of refraction. Okay. Now Snell experimentally obtained the law of refraction. We know these laws are as Snell's law. So first law is like this: the incident ray, refracted ray and normal are in same plane. And the second law is the ratio of the sine of the angle of incidence and the sine of the angle of refraction is constant. So we can see in this figure that here angle of incidence is I. So we can write that sine of the angle of incidence. So we can write like this: sine I. The sine of angle of refraction is R, and the sine and ratio. So divided by sine r is always constant, right? But here in this Snell's law, here we take constant like this n to 1. Here we say n to 1 is a constant called refractive index of second medium with respect to the first medium. So we can write that here n to 1 is a constant called the refractive index of the second medium with respect to first medium, right? I repeat, here n to 1 is a constant called the refractive index of second medium with respect to first medium. Here you can see in this figure that the incident ray passes through medium 1 first, and then it will traveling towards medium 2. So here we take refractive index of second medium with respect to first medium, right, as shown in this figure. So here we assume that suppose the velocity of the ray in medium 1 is v1 and velocity of medium 2 is v2, then the ratio of v1 upon v2 is also called as refractive index. I repeat, if we take velocity in medium 1 is v1 and velocity v2 in medium 2, then the ratio of v1 upon v2 is called refractive index. So we can write that if the velocity of light in medium 1 is v1 and in medium 2 is v2, then ratio of v1 upon v2 is called refractive index. So we can also write that refractive index is equals to n to 1 is equals to n2 upon n1 is equals to v1 upon v2, right? Refractive index n to 1 is equals to n2 upon n1 is equals to v1 upon v2, right? Okay friends, now here we take that if angle of incident is θ1 and angle of refraction is θ2, suppose angle of incidence is equals to theta 1 and angle of refraction is equals to theta 2. Then as per the Snell's law, we already studied that the ratio of sine of angle of incidence, which is sine theta 1, and to the sine of angle of refraction, so we can write that sine theta 2 is constant. So we can write that n21 is equals to n2 upon n1. So we can write that by cross product, n1 sin theta 1 is equals to n2 sin theta 2. So n1 sin theta 1 is equals to n2 sin theta 2. So we can write that n sin theta is equals to constant, which is known as Snell's law. Right? Okay. So here n sin theta is equals to constant, which is known as Snell's law or Snell's equation. So here, friends, we have to remember that refractive index n21, which is constant, and we can read like refractive index of medium 2 with respect to medium 1. We have to remember this formula, n21 is equals to n2 upon n1 is equals to v1 upon v2, and we have to remember this Snell's equation, n sin theta is equals to constant. Okay, now friends, we discuss about denser and rarer medium. Okay, now we discuss about denser and rarer medium. Friends, we already know from this Snell's law that sin I upon sin R is equals to n21, where n21 is the constant called the refractive index of second medium with respect to first medium. Right? Okay. Now, suppose if n21 is greater than 1, then we can say that sin I upon sin R is always greater than 1. Why? Because we already know that sin I upon sin R is equals to n21. So we can write that if n21 is greater than 1, then sin I upon sin R greater than 1. So here we multiply by here 1 to sin R, then sin I greater than sin R. We already discussed that if the angle is small, then sin theta is equals to theta and tan theta is equals to theta. So here we can write that sin I is equals to I and sin R is equals to R. So if sin I greater than sin R, then we can say that I is greater than R. So if I is greater than R, so we can say that refracted ray bends towards the normal. So medium 2 said to be denser as compared to medium 1. So here friends, this is our medium 1, this is our medium 2. This is rarer medium and this is denser medium. Right? Okay. So here this is incident ray, angle of incidence I. Now here refracted ray bends towards the normal. This is our normal. So after refraction, this refracted ray bends towards the normal. So here this is our refracted ray and this is our angle of refraction. Right? So if n21 is greater than 1, then sin I greater than sin R. So I greater than R. If I is greater than R, then refracted ray bends towards the normal as shown in this figure. We can also say that if n21 greater than 1, we know that n21 is equals to n2 upon n1. So here n2 is greater than n1. So here we can write that here n2 greater than n1, right? So if n2 greater than n1, then refracted ray bends towards the normal, right? So here this is our medium 1, so here n1 and here n2, right? So if n2 is greater than n1, then the refracted ray bends towards the normal. Now we discuss about second assumption here. If n21 less than 1, then we can say that sin I upon sin r less than 1. So sin I less than sin r. So I less than r. Also we know that n21 is equals to n2 upon n1. So we can say that n21 is equals to n2 upon n1. So that n2 is less than n1, like this. n21 less than 1. So that n2 upon n1 less than 1. So n2 less than n1 or n1 greater than n2, right? Okay, we can also say that if n21 is greater than 1, so n2 upon n1 greater than 1, so n2 greater than n1, right? So here n21 is less than 1, so n2 is less than n1 or n1 greater than n2. So here we can write that n2 less than n1 or n1 greater than n2. So here I is less than r, hence the refracted ray goes away from the normal. So medium 2 is said to be rarer as compared to medium 1. So here see this figure, friends. Here this is medium 1, medium 2. Here medium 2 is said to be rarer. So here this is our rarer medium. So here this is denser medium. Here first medium, refractive index n1, here n2. This is our incident ray, angle of incidence I. Now here refracted ray goes away from the normal. So here away from the normal. So here this is our refracted ray and this is angle of refraction R. Sorry, here angle between normal and right. Okay, angle between normal and refracted ray. So here this is angle R, which is known as angle of refraction, right? Okay, I repeat, n21 less than 1. So we can say that sin I less than sin r, so I is less than r, or n2 less than n1. Hence refracted ray goes away from the normal. So medium 2 is said to be rarer as compared to medium 1. So medium 1 denser, medium 2 rarer, right? After refraction, here refracted ray goes away from the normal as on this way. So this is incident ray, normal, angle of incident, refracted ray, normal. So this angle is angle of refraction. Okay, friends. Now one extra question for your G, NEET and GUJCAT. The tips for JEE, NEET or GUJCAT. Now, absolute refractive index. So we discuss about absolute refractive index. So here, if we assume the velocity of light is equals to c, and velocity of light in any medium by v then the ratio of C to V is known as absolute refractive index. So we can write that N is equals to C upon V, where C is equals to velocity of light in free space and V velocity of light in any medium, right? So if velocity of light in free space is denoted by C and velocity of any medium is by V, then absolute refractive index is said to be N is equals to C by V. This absolute refractive index has no unit, so this physical quantity has no unit, so we can say that this is unitless quantity. So unitless quantity. The dimensional formula here, C velocity, V velocity. So dimensional formula is m0 l0 t0, right? So this is important question for your examination. What is the dimensional formula of refractive index or absolute refractive index? So you have to answer that. Dimensional formula is m0 l0 t0 and unitless, no unit, right? Okay. Another, here we know that n21 is equals to n2 upon n1, right? And n12 is equals to n1 upon n2, right? So n12 is equals to n1 upon n2, or we can also write that 1 upon n21, right? Here n21 is equals to n2 upon n1. If we have to write n12, so that n12 is equals to n1 upon n2, right? Which is inverse of n21. So we can write that n12 is equals to 1 upon n21. So n12 into n21 is equals to 1. So this is important question for your examination. n21 is equals to n2 upon n1. If we have to write n12, then n12 is equals to n1 upon n2, which is inverse of n21. So n12 is equals to 1 upon n21. By product, n12 into n21 is equals to 1, right? Okay. Now friends, we discuss about lateral shift. Suppose we put here one rectangular slab. Suppose this slab is made of glass. Then see, here this is our medium 1 air, this medium 2 glass, thereafter this is medium 3 air, right? Okay, so here there are two interfaces. First interface is this between air and glass, and second is this between glass and air. So here see, suppose one ray AB is incident at surface 1 and 2. So here incident on this interface between air and glass. So here incident ray and normal. So here this is our angle of incident I. Now here there are two mediums, air and glass. So here air is our rarer medium and glass is denser, right? So ray has to pass from rarer to denser. So we know that the ray is moved towards the normal. So here the ray passes like this, right? So here this is our refracted ray B C. This is normal. Now see here, this is angle of refraction. Here we denoted this angle by R1. By geometry here you can see this is Z. So if this angle is R1, so this is also R1, right? Now we discuss about this interface number 2 between glass and air. Now glass denser and air rarer. So when rays passes through denser and at last rarer, so the ray travels away from the normal. So ray passes like this, right? So this is angle, this angle is we denoted this by I1, and here we denoted this angle by I2, right? Okay, now here we denoted this by not I2, this is R2, because this is refracted ray, right? Now if there is no slab, then this ray is passed like this, right? But due to the slab, the ray experience some displacement, this, right? So this displacement is known as lateral shift, right? So due to the slab, a ray experience a displacement, and this displacement is known as lateral shift. Here from the figure, for interface 1, if we have to use Snell's law, so here theta 1 is I1 and theta 2 is R1. So N1 sine theta 1, which is I1, is equals to N2 sine theta 2, which is R1. This is our equation number 1. Now for interface 2, here this is N1, N2, air, so N1. So for interface 2, instead of N1 we have to write N2. So N2 sine theta 1, which is R1, is equals to N1 sine theta 2, which is R2. So we can write that N2 sine theta 1, which is R1, is equals to N1 sine theta 1, which is R2, number 2. Here we can also write that N1 sine R2 is equals to N2 sine R1, right? Interchange this. So see equation 1 and equation number 3. The right hand side are same, so we can compare left hand side. So from equation number 1 and 3 we can write that N1 sine I1 is equals to N1 sine R2, right? Here N1 cancel, so we can write that sine I1 is equals to sine R2. If angle is small, then we can write that I1 is equals to R2. So here instead of R2 we can also write I1, because here we prove that I1 is equals to R2. Now for exams like GNET or GUJCAT, you have to remember the formula of lateral shift. So here lateral shift is equals to, you have to remember this equation, T into I1 into 1 minus N1 upon N2, where T thickness of this slab, I1 incidence angle, N1 refractive index of rarer medium, and N2 refractive index of denser medium, which is glass. I repeat, lateral shift is equals to Ti1 into 1 minus N1 upon N2, where T thickness, I1 incidence angle, N1 refractive index of rarer medium, which is air, and N2 refractive index of denser medium, which is glass. So here T is equals to thickness of slab. Other data you already know, I1 incidence angle, N1 which is refractive index of rarer medium air, and N2 refractive index of denser medium, which is glass. Okay, so this is for today's session. Okay, thanks.